Welcome everyone to the final topic of functions, known as rational inequalities. From an earlier lesson, we learned that rational functions are when we have a polynomial over another polynomial. Now we'll be solving inequalities to do with them. For example, this inequality over here. The first and only rule with rational inequalities is do not cross multiply. Now let me give you a simple explanation on why this is so. Let's say we have this inequality, 2 over x is more than 3. If x is positive, then we can multiply normally. However, if x is negative, we will need to flip the inequality. This means that for certain ranges of x, you may have to flip the inequality, and for other ranges, you may not need to flip the inequality. In order to avoid all this ambiguity, we just don't cross multiply. Okay, let's attempt this question. If we don't cross multiply though, how are we supposed to simplify this? There's a nice solution. We move everything over to one side. So we have x over x plus 8 minus 1 over x minus 1, which is less than or equals to 0. Now I've combined this into a single fraction. What I want to do is simplify it further. If I expand out the numerator, I'll get x squared minus 2x minus 8. But we are not done yet. What we want to do is factorize everything into linear factors. Aha! Now after we factorize the quadratic, all these over here are linear factors. What are these linear factors supposed to do? These linear factors actually all give you this thing called a critical value. The critical value is when your linear factor is equals to 0. Let's find all the critical values and plot them on a number line. First of all, we have negative 8. And then we have negative 2, 1, and then 4. What we want to do is determine between each of these values if this entire thing is less than 0 or more than 0. So let's do a bit of testing. If we want something below negative 8, we can have negative 9. So if we sub in negative 9, if we look here, this will be negative, this is negative, this is negative, and this is negative. Oh, so all the negatives cancel out, and this becomes positive. Now we substitute a value in between negative 8 and negative 2. So let's say we want negative 5. This will be negative, this will be negative, this will be negative, and this will be positive. These two negatives cancel out, and we are left with a negative over positive value, which is negative. Actually, as long as there's no repeated factor, meaning something like this, x plus 2 square, the signs will just be alternating. So you have plus minus plus minus plus. And here we want to find the range of values when this is less than or equals to 0, which means we are finding this range of values and this range of values, because over here, these two are negative. So now we can say that x is between negative 8 and negative 2, as well as x is between 1 and 4. Now this one over here is inclusive and this one over here is inclusive, because this is inclusive of 0. But what I want you to know over here is that we cannot also put this inclusive sign for 1 and negative 8. Why? If you look very carefully at the denominator, we cannot have x equals to 1 and x equals to negative 8. That's why I still have to leave this out and say that it's strictly more than negative 8 and strictly more than 1. Alright, here's a summary sheet for rational inequalities. Again, to recap, do not cross multiply. What you want to do is move everything over to one side and combine it into one fraction. And then we find the critical values, which can help us to find the answer. And here's the summary sheet for everything to do with inequalities and roots of a polynomial. Thank you so much for watching.